Okay, so here we have to evaluate the limit as x approaches 3 of x squared plus 2x minus 15 divided by x minus 3 squared. So how do we do this? Well, first anytime you have a limit, it's always good to try and plug in the number to start. So if you plug in 3, right, we have 3 squared, that's 9, plus 2 times 3, that's 6, so 9 plus 6 is 15, minus 15 is 0, and if you plug in 3 into the denominator, you can see you get 3 minus 3, that's also 0, and so we have 0 divided by 0. So that's not a good look for our limit, so we've got to figure out some other techniques that we can do. So what I'm going to do is I'm going to factor the numerator. Factoring is always a good key when you have at least quadratics, polynomials in general. Usually you can find some cancellations. So in this case, I can factor the numerator into x plus 5 times x minus 3, and I get a cancellation, right? X minus 3 and one of the x minus 3 factors in the denominator get canceled. And so my limit becomes the limit as x approaches 3 of x plus 5 divided by x minus 3. But again, it's not clear what this limit is, because if I plug in 3, I'm going to be dividing by 0, right? So this function is still not defined at 3. And so what I'm going to do is I'm going to check the one-sided limits, because we know if the one-sided limits are equal, then the limit exists, and whatever they are, that's the value. If the one-sided limits are not equal, then the limit does not exist. So here we go. The one-sided limit from the left, right, from the negative side of this expression, there's kind of a rigorous way to do it, like the product rule, using the product rule for limits, but just take a look at what happens here as x gets very close to 3 from the left side. So in other words, plug in numbers like 2.99, 2.999, numbers very close to that. Just kind of in your mind, right? What's going to happen here? The numerator, 2.9 plus 5, that's what, 7.9, whatever, positive number, right? Whereas in the denominator, 2.9 minus 3, that's going to be a very, very small negative number. And if you chose a number even closer, right, like 2.99999 minus 3, that's going to be a very, very small negative number. So in other words, positive number divided by small negative number is going to give you a very large negative number. Remember, when you divide by a very small number, that's like multiplying by a very huge number. So in other words, this is going to approach negative infinity. And on the right side, you can see here, we're going to have a similar effect, but opposite, right? Plug in a number close to 3, but that's on the positive side. So say like 3.01. Again, in the numerator, you're going to get 8, whatever, constant number, right? But in the denominator, you're going to get a very, very small positive number. And we take a positive number divided by a very, very small positive number, we're going to get a very, very large positive number. And so this limit is going to approach positive infinity. And you can see the one-sided limits are not equal. And so we say that this limit does not exist. And so that is your final answer.